In order to make new generation aircraft engines, we need to make larger fan with higher bypass ratio. The composite technology is required to reduce the weight of the fan because at this size of engine, a metallic blade would be much heavier, and therefore we introduce this kind of new technology, the 3D woven composite fan blade. The composite technology we use is very different from what is used in the aircraft industry. We take the carbon fiber and weave in 3 dimensions the full blade. So we have a tough technology, very robust, very damage tolerant, and with complex shape like this one that allows to have very good efficiency of the fan.
The fan case is located at the front of the engine, just around the fan blades. The main goals of the part are to carry the load from the engine and also support all the equipment which are located in a fan compartment, and finally contain all the debris in front of the engine. The innovation at CFM is to do this part with a composite material. We use a specific type of composite, the 3D woven composite, to do this part. This allows us to gain some weight. To give a rough idea, we gain about 30% weight compared to the classical structure in metallic as aluminum, for example.
For LEAP engine parts, we first start with carbon fiber. We weave it to get a 3D woven preform. We trim it and we then form it to shape the 3D structure of the parts. We can then place the parts in a mold and use a resin transfer modeling technique in order to inject the resin and get the as-molded part. Once this is done, we can then machine and do the finishing operation. A lot of tests have been performed, from very simple tensile coupon test to very complex fan blade out test. More than 3,000 parts have been manufactured and tested to date. CFM will manufacture these composite parts in 2 brand new plants. The first one will be located in Rochester, New Hampshire, here in the United States. Second one will be located in France, in Commercy.